Okay, so that's all well and good, but how do you know where the mode-restricted subbands are and which modes to use on them? Like, what if you don't know it's a mode-restricted subband and you accidentally transmit voice over there? How do you know where the mode-restricted subbands are? How do you know where anything is on ham radio? Like, how do you know where the band limits are, which bands you can use, and where in the bands you can transmit, and what modes you can use on which part of the band? So you might be wondering, is there some sort of chart or something, or a piece of some sort of information that tells you where you can and cannot use various modes on a certain ham radio band, and maybe what frequencies you're allowed to operate on within that band, and et cetera, et cetera? And the answer is yes, and this is actually called a band plan. And if you're very confused by what I just said, we'll clear this up by looking at an actual band plan in a minute. But first, just know that band plans are basically, they're voluntary guides that tell you where you can use different modes or where you can participate in certain activities on the bands. So it's basically, a band plan is just a piece of paper, and on that paper it marks out what you can do on a certain band, like the 20-meter band, and where on the band you can use a certain mode. And band plans also specify where you might participate in certain activities. For example, if you want to do the activity of DXing, which, by the way, DXing means talking to people outside of the country, then the band plan might actually suggest an area on the band, a certain frequency that you can use for that purpose. That's what we mean by band plans. And the same thing goes for ham radio modes, not just activities. So hams in general, they establish these band plans. They're not really set up by ham radio clubs. The test might try to trick you with an answer choice that says band plans are created by clubs. That's not true. So the next topic we need to learn about for the test is the what we call a national calling frequency. Okay, so what exactly is a national calling frequency? And I wrote some notes on the national calling frequency up here. But the national calling frequency, it's basically just a designated place on a certain band where people hang out. It's a designated place where people hang out on a certain band. You see, some of these ham radio bands, they're very large. They have a lot of frequencies in it. It might stretch all the way from here to all the way to over there. And if all the people in the band are just sort of scattered, some people are over here, some people are over there, they're just scattered all in the middle, it can sometimes be hard to find someone to talk to on ham radio, because you might go up to a random frequency and call out for someone to answer you, but if no one else is there on that frequency because they're all scattered somewhere else, that's not really going to work. No one's going to hear you. So what we need is a central place where all the hams can hang out, so that if we're looking for someone to talk to, we know, okay, I can just head over here and there are people there and I can talk to people, talk to other hams on this frequency. And that's basically what the national calling frequency is. With the national calling frequency, everyone hangs out on that national calling frequency. So if you want to find someone to talk to, you can just go right to the national calling frequency instead of trying to jump around all over the band trying to figure out where everyone else is. You know where everyone is. And it makes things a lot easier when you're trying to find someone to talk to on ham radio. Now, the technician class exam actually expects you to know that the national calling frequency on the 70 centimeter band is 446.000 megahertz. So that's basically where everyone hangs out on 70 centimeters. If you want to talk to someone or call someone on 70 centimeters, that's the place where you usually go, because that's just the standard place, the designated place where people are supposed to hang out. So now let's talk about something else that is very important in regards to your technician frequencies and how you use them. And that something is interference. In other words, interfering with other signals on ham radio. And the interesting thing is that it turns out that not all of your tech frequencies, not all of the frequencies you're going to be allowed to access as a technician class operator, not all of those are going to be ham radio only frequencies. Meaning that some of these bands, they accommodate not only hams and ham radio operators, but other stations as well, stations that aren't necessarily ham radio stations, other types of stations like geolocation stations or other things like that. So in fact, sometimes you might even find non-ham radio stations operating on the ham radio portion of your ham radio band, and this is actually loud sometimes. So for instance, what we call radio location stations from outside the United States actually operate sometimes on the 23 centimeter band, which is a ham radio band. But the thing is, they're allowed to do that. We're supposed to share the band with them. So you may not cause interference with radio location stations. If you're on the 23 centimeter band and you find out that you're interfering with a radio location station from outside the United States, you're actually required by FCC rules to stop operating or do something to stop interfering with that radio location station. You have to share the band with them. And another example, hams are actually secondary on the 70 centimeter band. And when I say they're secondary, I mean that there may be non-ham radio stations operating on that band, and those other non-ham radio stations actually have first priority on that band. Ham stations don't have the first priority. And what this means is that you cannot interfere with the non-ham radio stations on the 70 centimeter band. You have to let them transmit, and you have to stop transmitting. You can't interfere with them. They have the first priority on the band. Hams are only secondary. Okay, so with that out of the way, interference, we're almost done looking at tech frequencies, and there's really just one more thing, sort of a warning about your technician class frequencies. And that warning, which is actually on the test, is that you should never transmit on the very edge of the band. You shouldn't transmit on the edge of the band, which is written here. So what do I mean by that? What is the edge of the band? What does it mean to transmit on the edge of the band? Well, say you're on the 2-meter band. Now, if you look at the band plan, on the 2-meter band allows you to operate from 144.1 to 148.0 megahertz on voice. So the band, basically, it stops once you reach 148.0 megahertz. That's the limit of the band. The band stops there. You can't transmit outside that because that's not the 2-meter band anymore, and you don't have privileges there. So when you're operating on 2 meters, you should never set your radio right at 148.0 megahertz, the upper band limit. And why not? Well, you might accidentally transmit above 148 megahertz if you do this, and this is due to a variety of reasons. For example, your transmitter might experience what we call drift, where sometimes we set our transmitter to transmit on a certain frequency, but it sort of has a mind of its own and actually kind of drifts over here and says, no, I want to transmit on this frequency. And if we set it to 147.005 megahertz, it might actually drift over to 147.010 megahertz and start transmitting there. It just sort of develops a mind of its own. And believe it or not, this does actually happen. So we don't want this to happen, because if we're on 148 megahertz transmitting and it accidentally, the transmitter drifts to another megahertz like 149 megahertz, that's not good, because we're not allowed to transmit in 149 megahertz. And another reason to not transmit on the very edge of a band is because your display might sometimes be wrong. Like your radio display might say you're transmitting on 148 megahertz, but it might be miscalibrated, and you might actually be transmitting on 149 megahertz, which is, again, not good. So your display might be wrong, or your signal might just be wide, so wide that it goes outside of the band limits. Remember, we just talked about bandwidth and how when you're transmitting voice and audio over ham radio, the signal is very wide. It takes up a lot of frequencies when you're transmitting that voice because a lot of information needs to be conveyed. So if you're talking on 148 megahertz, you might actually, because the signal's so wide, the signal might be so wide that it stretches outside the 148 megahertz limit, and you start transmitting signals on 148.005 megahertz, which is outside of the band. And you're not allowed to do that, so you need to be very careful. Because if it does go over 148 megahertz, that's illegal. So you need to stay clear of the band edge. You need to keep some distance, keep some wiggle room, so that in case something happens and your transmitter starts transmitting above the frequency you wanted to transmit on, you still won't violate any rules. So instead of transmitting on 148 megahertz, you might transmit on 147.990 megahertz, and that leaves 10 kilohertz of wiggle room to make sure you don't get too close to the end. Okay, so that's the end of this very hard section, tech frequencies, which I think is the hardest section we've studied so far. So if you're having extra trouble with this, don't feel too bad. And if you have any questions or are confused on anything, feel free to send me an email.